Hey guys, today I want to talk about volumetric fog in mobile devices. As you know, there's no volumetric fog in mobile devices. There's no pre-built volumetric fog. If you want to create something, you have to do it for yourself and you have to fake everything. You can't like simulate all the lighting and all the beams coming from everywhere, all the God rays. You cannot simulate all of those. If you want to do so, you have to go ahead and fake everything that you can, just create them for yourself. So I'm not going to, just a disclaimer, I'm not going to talk about exponential height fog. This is so expensive on mobile devices. I had, I guess it was 2 years ago or something like that. I had created another video in another channel, which was I was telling you to go ahead and use this one. That was a mistake. My bad. Don't use it. It's so expensive and it's not volumetric. But instead, I found another way to do it. So it's just a sphere. You can go ahead and create any mesh that you want. And what we're going to talk about is a material. So we're going to just go ahead and create the material for ourselves. This is a material instance. So I'm going to go ahead in the parent section and I'm going to show you how I've created all the things. I found this piece of material in the art station though, so it's not something that's coming from me. The first thing that you have to um, it's really important that you have set the blend mode to additive. The material domain is surface, but shading model must be unlit. Default lit is expensive, really. It's really expensive. Um, so just go ahead and pause the video for a second. I'm not going to create the system from scratch, so if you feel like you have to duplicate what I did, just go ahead and pause the video in anywhere that you want. So it's not going to be two-sided because, you know, sometimes you may feel like you need it to be two-sided because you want to go inside the mesh, like you want to go ahead inside the mesh, but instead what I did was to make sure that the mesh disappears when you get close to it. So anyways, um, so this is the code. We're gonna take the pixel depth node, multiply it. If you didn't know, you can just hold M and left click to have the multiply node. And if you want the scalars, you can just hold S and left click and divide two scalars. One is for hardness, one is for distance, and the default value is this for myself. For this one is this, and divide them and plug them into the multiply with the pixel depth. Then we're gonna clamp it. So clamp is like, just type it out, clamp. That's it. Um, clamp it by 0 and 1, and then multiply it by something else. So we have two scalar parameters coming to the Fresnel node. Just type in Fresnel, and you have the node here, and it's going to 1 minus, and then abs, just type abs, and it's going to the power node. Another scalar parameter is going to the exponential. So this is not used. So this is an old code, which if you use this code, it's not going to render in the mobile devices. It's going to show you the fog in the previewer though, but it's not going to show you anything in mobile devices. And if you go ahead and debug everything, you'll see that the fog's there. It's not just showing anything, and the problem is because of this piece of code. So don't use this. If you know the ArtStation article that I'm talking about, please remove this code from the material. So after the multiply, we're just gonna clamp it by 0 and 1, and then multiply by another scalar called opacity with the default value of 0.776. and then we're gonna multiply it by something else that we need now. So, um, yeah, this piece of code is for the part where you want to, when you are getting close to the sphere, it just fades away. I believe this is very needed, but if you just go into the shader complexity, I mean, this shader complexity is not accurate because it's not set to Android ES 3.1, but I'm just gonna go ahead and show you that uh, when the mesh is fading away, it's not like it stops rendering the mesh. It is there. It's just not visible in the screen. So don't ever think of it like you can use 1,000 of meshes and just make them fade away, because GPU is rendering them and there's a power dedicating to them. So don't use it that way. So it's coming from a pixel depth to a sphere mask with a scalar parameter or anything. I just use the value of 0, and the radius and hardness is 534. And 1 minus to multiply to this, and it's going to the opacity. So this will be the opacity part of the material for the emissive color. Oh, and since this is on lit, we don't have the base color or any kind of that good stuff. We just have the emissive color, which is fine for us because we don't want to simulate any kind of light or refraction or anything. That's too expensive for mobile devices. Um, so for my part, I want to be able to specify the color. So just go ahead and create a, what was it called? Vector parameter. Yeah, a vector parameter. Um, so it's going to be a parameter in your material instance and multiply it by a scalar parameter with the default value of this. And multiply it by the piece of code that you have for fading the whole thing away, because I mean you don't need to multiply it. I mean, I don't know, just test it out and see which one suits you. Okay, this is for the base material. I'm just gonna go ahead and click no. After that, you just go ahead and right click and create material instance, and just drag the material instance to your scene. So these are the values that I'm using at the moment. So if you just want to make it more glowy, you can go ahead and do so. If you want the gradient power to be more, just go ahead and do so. But for me personally, these are the values that are working better. And you can just go ahead and change the color as well. Okay, so this is the first material that I've created. So the second part is, I mean, this material's performance is not bad for high-end devices. I would say that in mobile devices, in Android for high-end devices, it's gonna cost you for like 1 millisecond, which is perfectly normal. So you can give the audience the ability to turn on and off the fog with just changing the visibility. I've noticed that if you just uncheck the visibility, the GPU won't render it anymore, and you can get all the frame rate that you've been losing back. So they can easily toggle off the fog for themselves. Um, and we have the noise coming to the party. So let's go see this one. So all the code is completely the same. I mean, what I've shown you was this piece of code. You can go ahead and add a noise to it. Uh, what I'm using is these values, scale this one, levels, and yeah, I just, oh, and it should be texture based. And you want to create an object position, absolute word position, and subtract these two and add them to the time multiplied by a um, scalar parameter, which for my case, the default value is 0, and just add everything you have here except this one to the position of your noise. And then you can go ahead and multiply it by the opacity, because we want the opacity to have all these animations and stuff. If you can see it, I'm not sure if you can see it correctly, properly as you should, because because of all the compression in YouTube and all. There's an animation here, so you can just see the clouds are literally moving. This is another method to create this. And again, you can just go ahead and right click, create material instance, and change the values. But personally, I wouldn't recommend this method because, at first I thought that it may not be that expensive, but it was. It was actually pretty expensive, even in high-end devices. So I would say that it was having a total of 5 milliseconds of cost, which is not ideal for a case. The best method I've found is this method, which you can see it's simulating the whole fog. It's so similar to a complete volumetric fog. So this is the best way that I could find actually. Um, okay. So the whole code is so similar. It's completely the same, except I just added a texture. I downloaded this texture from Google. You can go ahead and do so. Uh, and just I multiplied it by, let me see. Yeah, doesn't really matter. So I just multiplied it by all the nodes that are going to the emissive color. You can go ahead and do so with the opacity as well, and test it out for yourself. If it's better performance wise, I'm not really sure. You just, the thing with mobile devices is that when you do something and you don't know the result, no one else knows it. So you have to go ahead and test it out for yourself. And if you could, please report it in YouTube or in a forum or anywhere actually, so others can know as well. And yeah, this is the best method. Performance wise, it's so similar to this one. So it's pretty much like nothing. And I was almost forgetting this. For low end devices, the performance is like could be up to 4 milliseconds. So it's not that bad. If they want to use, what I'm talking about is not for just one cloud. You can have at least 10, 15 clouds in your scene, and for high-end devices, the performance hit will be 1 millisecond, and for low-end devices, it will be 4 milliseconds to 5 milliseconds roughly. So you can go ahead and create 15, 10 clouds in a scene, and you can easily get away with it. It's not that heavy. But yeah, that's it, guys. If you just, I'm just trying to show you every piece of code I have here, so you could just pause it and maybe double check your code. And this is the whole. And yeah, that's it. I hope it helps you, and if it did, please hit that like button. And if you do like what I do here, please hit that subscribe button as well. And if you have any questions, please let me know in the comment sections. Have a great day. Bye.